Like any creative process, building and designing piping system models is shaped by individual preferences. FluidFlow offers a wide range of customization options, enabling you to tailor the appearance and functionality of the user interface to suit your preferred workflow. The first set of options can be found under the View menu, where you'll have a variety of options to customize your workspace. First, you can adjust the visibility of the input editor and the data palette. For example, you can hide them entirely to maximize the flowsheet area. This can be especially helpful when building complex models. Next, you can choose whether to show or hide the components bar and the component palette. You also have control over which tabs are displayed within the data palette, giving you flexibility to tailor the interface to your needs. You'll also find options to display the scripting window and the data report window, as well as toggle the visibility of the different toolbars here. Additionally, you can cycle through different user interface appearances, letting you pick a style that suits your preferences. Finally, these three buttons at the bottom let you quickly reset the menus, user interface layout, and form positions to their default settings. Additional view options include the ability to unpin the input editor or the data palette, allowing them to retract when not in use. Additionally, both the palettes and any of the toolbars can be docked if preferred. The calculation options, located under the Options menu, allow you to specify some important parameters regarding the calculation methods used in your model. The first tab simply displays some information about the currently active model. The next tab allows the user to open up the convergence criteria. This can be useful for large, complex networks which are struggling to converge. It's important to use the Reset to Defaults button to restore the original settings when finished to maintain the highest level of accuracy. The global settings allow you to define certain constants and assumptions for your model. For instance, the Assume Zero Flow enables the software to close a pipe when negligible flow is being calculated in a pipe, which helps converge systems. The inclusions allow us to automatically include a correction factor for centrifugal pumps handling high or low viscosity relative to water, or to automatically include losses due to reducers and expanders on either side of the valve. You may also enable the software to iterate to a solution for friction factor across all possible flow regimes. Here, you can specify the reference conditions for gas systems, either normal or standard. In the Two-Phase tab, you can specify which method you want to use from the list available. The Wally method automatically selects from one of the three based on some predefined criteria. The non-Newtonian and slurry tab allows you to select the modeling correlation for settling slurries. You can also choose the method for calculating the maximum deposition velocity and define specific constants required for certain correlations. Lastly, Pulp and Paper Stock allows you to select a correlation and also define the Tapai pulp size, or the fiber aspect ratio and pulp freeness if using the Mahler method. The Flowsheet Options dialog allows you to customize both the appearance and functionality of the flowsheet. Here, you can adjust the size of the flowsheet and the scale at which it is displayed in the interface. You can also configure the grid size, toggle snap options, and select a background color for the flowsheet. The Split Pipe on Insertion checkbox determines whether FluidFlow 3 splits a pipe when a component is dropped onto it. For example, if you place a valve onto a 10-meter pipe, the software will automatically divide it into two 5-meter pipes, one on each side of the valve. In the Components tab, you can control various flyby options. For instance, you can enable or disable flybys, make them transparent, or toggle some of the information shown on the flow sheet. Options include showing unique names, node numbers, and pipe numbers. You can also turn off the warning highlight, display element properties, and customize the colors of different components on the flow sheet. The environment allows you to specify a predetermined set of options, which include export options, visible results, and results units. We'll talk about exporting in more detail later, but for now, let's create a new environment to view this model in imperial units. To start, we need to save a new environment to avoid modifying the default sets provided. Let's name it Water Systems Imperial Units, and then click Save. Once saved, we can now select our required environment from the drop-down menu here and easily switch between unit sets. Next, we'll make changes to the new environment. Let's specify the units we want to use by navigating to Options, Environment, and selecting Result Units from the options. From there, set the units as needed, and click OK to apply the changes. This feature is also helpful when working with gas systems. For instance, you may prefer to view flows in mass terms rather than volumetric flow rates, depending on the system's requirements. In such cases, you can create a custom environment specifically designed to meet the needs of that system. Next, the Warnings and Hints dialog provides users with control over when warnings are enunciated. While most warnings are fixed and cannot be disabled, some are discretionary and can be toggled here. Additionally, you can also set specific limits, such as velocity and control valve opening limits, for liquid, gas, and two-phase flow systems. Finally, you can choose the display language here. In our next video, we'll get back into designing our system, demonstrating how to balance and control flows while sizing pipes effectively.